how much dust would Thanos make? Now, like the title of this video says, there will be no spoilers during this live stream, and I hope you can respect to not spoil the endgame as well. If you are in the chat or asking us any questions, we really don't want to have to ban you forever, but we will, and I won't really care about it. So please do not spoil endgame for anyone if anyone in the chat hasn't seen it. Now, all that being said, no spoilers. How much dust would Thanos make? Well, to make that kind of estimation, we have to think about it in a very sciencey way, as we are wont to do on this channel. How much dust would the average person make? Well, to me, it seems like when someone is dusted, they are reduced to a kind of ash, or at least something light enough that it can blow away in a light breeze. I just thought of that at the top of my head. So it has to be, it has to be very light. It has to not have a whole lot of material left. What could that be? Well, let's look to cremation. How much ash does the average person produce when they are cremated? Well, this is for our imperial units. I'll use both. But for our imperial unit friends, this is between 3 and 9 pounds. Well, if you multiply that by half of the world's population, we are just considering Earth now. If Thanos snapped Earth, then this is half the population is going to be around 34 billion pounds of ash, or 15 billion. I know that's not proper scientific notation. Kilograms. Now, if you're snapping the whole universe, obviously, when Dr. Strange says you might be killing trillions in this snap, obviously this number would be much larger. But since we can only work with the data that we have here on Earth, we're going to stick with this number for a second. Now, one of you has asked me before, what would all this dust do to the Earth? Is it enough to be affecting weather systems, for example? Well, now we have to make another sciencey comparison yet again. What kind of ash content in the Earth's atmosphere would it take to, say, trigger a small ice age or something like that, which has happened in Earth's history? Well, if you look it up, you can find values for ash from something like super volcanic eruptions, which release plumes of ash into Earth's atmosphere. So much ash that it can blot out the sun and trigger small ice ages and drastic changes in temperature. Now, if you look up what the value for an average supervolcano is in terms of how much ash it throws up into the air, that is around 7,000 trillion kilograms. Now, I don't know if you can do the math off the top of your head right there, but if you dusted half of the human population, the amount of dust that you would get is about 0.002% how much a supervolcano throws up that could affect the Earth's atmosphere. So that doesn't seem like it would do anything at all. But remember that Thanos is not just dusting half of humans. Canonically, or at least in the movie, and according to Kevin Feige, they are dusting half of life on Earth. Okay, so now we have to make another comparison. It is estimated that there is about 550 billion tons of carbon held up in life on the planet Earth. Now, if you take half of that, 225 billion tons, convert that to kilograms, then what do you get? Well, if you dusted half of all life on Earth, and this, yes, includes dusting like all the fish and stuff and having their dust enter the atmosphere, let's just forget about that for a second, you still only get 3% of this value. So, if you dusted feasibly all of the life on planet Earth, there would be a lot of ash, but there wouldn't be even it wouldn't even be 5% of the ash that is thrown up during a massive eruption like this. It wouldn't probably affect the atmosphere all that much, considering the percentages here. But that might be disappointing, I guess. But think of just how much material is thrown out during a super eruption. That's why this is so scary. A super eruption will throw more ash into the air than the weight of all humans put together in ash at once. That's rough. Good thing Thanos only snapped half of us, I guess. Hello and welcome to another edition of Because Science Live, the live part of this channel where I take all of your comments, questions, and corrections, not about Endgame this time, and I try to address them off the top of my head to the best of my ability. Look, this is a science channel. I consider myself an educator, but I do not consider myself an expert. I'm not a working scientist. However, I know a little bit about a lot of sciencey and pop culture things, so if you have any questions for me that I can attempt to answer or redirect into something that I know about, hit us up in the chat. Be kind, don't spam, don't spoil, and we might read it out loud as we are about to do right now. Nate?
Hey Kyle, what's up?
I don't know, dude. I'm just chilling with all this
Okay.
What's our first question?
From Dave Sharma.
Dave Sharma, brother of Chris Sharma, one of the best climbers in the world.
If you could possess only one Infinity Stone, which one would you choose and why?
I have a sneaking suspicion that the Time Stone would be immensely powerful, although if I had to choose, it's hard. If you had the Reality Stone, you could live a life exactly of your own choosing. Just, I wish for it. This is, a very Western a materialistic view of it, but you could say like, I'm going to just manifest a Lamborghini or something like that, and you could live a dope life where you have vape pens and stuff. But if I had to choose, I would probably go with something like the Space Stone. If for nothing other than I want to see if there's other life in the universe. It would be the most important realization that humans have ever had, ever. If we could say just pop to Europa, check beneath the ice, and see if there's life or some other place, or just start planet hopping and galaxy hopping with the Space Stone so you can see if there's other civilizations in the universe and you weren't immediately killed by that civilization or dissected. That would be amazing to me. I think what's beautifully tragic about mankind at the moment is that we are limited by our travel technologies, limited by the speed of light, such that you could probably draw a sphere around Earth, a hypothetical sphere that would show you how far we could ever possibly get away from Earth. And at some scale, it would look like it's about the same size of Earth as Earth. It's probably not very far if you're looking from the Andromeda Galaxy or something like that. So it's kind of tragic that we'll probably never get out to, say, the galaxy right next door. That's why I think things like the Time Stone would be an incredible experience to finally break the chains of the light speed limit kind of thing. So I think that's what I would go with. Or I would take the Time Stone and replay it until I got that high score in... What's a game out today?
Game out today. The day's gone?
Sure.
All right.
What's next?
From Esteban B.
Hello, Esteban.
Is the core of the moon like Earth's core?
I don't know. I don't know if the Earth, well, so the core of the moon, I don't want to say anything that I don't have any expertise in, but I believe the core of the moon, well, either the moon doesn't have a spinning core or something else is happening. The core of the moon is dead. And what I mean by that is it's not spinning like a dynamo that's creating some kind of magnetic field that can shield it from radiation and what have you. So at the center of, at the center of Earth, let's say, at the center of Earth and our planet that we call home, there is a lot of molten metal at the center. And one of the properties of spinning globules of metal is that it can produce electromagnetism. It can produce a large and wide-ranging magnetic field, for example. So from the core of our Earth spinning like a dynamo, you get this protective shell of magnetic fields and magnetic field lines that extend out from Earth like this. And then any incoming radiation from the sun, like really harmful radiation, a lot of it can be absorbed, diverted, what have you, such that it doesn't erase all the life on the surface of the planet. You think ultraviolet A and B rays are bad and they give you sunburn. If the Earth didn't have a magnetosphere, I think our atmosphere would be slowly obliterated, and then everything would die. I think that's what happened on Mars. Solar winds slowly obliterated its atmosphere. So all that is to say is that the moon doesn't have something like this going on. So on the surface of it, there's a lot of harmful radiation. So I do not think the core of the moon is like the core of the planet Earth in that it has this thing that can generate a magnetic field, which is very important to us. What's next?
From Jordan Stokes.
Hello, I'm stoked to hear your question.
Ooh. What would happen if you were in the hollow core of a planet? Would you be pulled equally in all directions and experience 0G?
What's with all these planet core questions? Yes, exactly. So when you think about gravity, what a weird general thing to say. When you think about gravity, it's pretty dope, right? No, so if you are, let's say, if you are a human being, as you are, I can prove that. If you're a human being and some amount of mass is away from you, let's say it is here, some amount of mass is away from you, just because of the laws of nature, it will exert some force on you, a gravitational force, as we call it. So that will pull you in one direction, like the band. Now, what happens if you start changing the distribution of this mass? Okay, so now you're being pulled in these directions. What happens if you change it even more? And the distribution of the mass is, let's just say that's a perfect sphere. The distribution of mass is all the way around you in a perfect sphere. Let's just say the Earth is a perfect sphere as well. And so it's all the way around you, and it's evenly distributed. Now, you can imagine little arrows that are pulling you towards the same amount of mass in every direction. And if you have the same amount of force in every direction, including the opposite direction that I just drew, for every arrow, you can find an arrow that cancels it out. So this arrow pointing exactly this direction in, let's just say, it has a length of 1. This arrow with a length of 1 is canceled out by this arrow in the exact opposite direction with a length of -1, equaling 0. Same for the top, same for the bottom, same for every single orientation in a perfect sphere. So if you carved out a perfect sphere in the center of a perfectly spherical planet with a perfect distribution of mass, which we are assuming the Earth has right now, then yes, you would sit at the exact center, pulled equally in all directions, and therefore you go nowhere, and you float. Now, like I said, you can prove this by taking the Earth in shells and seeing what the distribution of forces is at every level. And if you were at the exact center, you would have this cancellation of forces and you would float there, just at the center of the Earth, like some subterranean creature. However, the Earth is not perfectly spherical. It's not the same density in all of its places. So it easily could be the case if you were in a hollow planet, that you would just kind of float to one side of the hole and just like stick there. Probably. Nature isn't perfect. It's messy, like us. What's next?
From Aaron McGraw.
Aaron McGraw.
What is one of the most amazing feats of evolution in your opinion?
Complicated philosophical question. We always have to remember that evolution isn't trying to do anything. So if you see an animal with some amazing adaptation, you have to know that there wasn't a plan or a will that said, okay, you started out as primordial soup and then you're going to have wings, baby. I mean, there is nothing like that. It is, of course, impressive what some animals have evolved to do, but there's no will behind it. They simply have random genes every time they are born. There's some genetic throw-up, and nature selects for what works. There's animals for which it doesn't work, and those genes are removed from the gene pool by being eaten. So what tends towards continuing on the population is just what works at the time. And at every point in time, it's not considering what is in the future of that past. Oh, we're getting time traveling now. But at every point in the future, there isn't a large jump. So it doesn't go from no wings to wings. It goes from no wings, and then every single possible degree of kind of wings until you get to what you could look at and say, those are wings. So there are animals that we can see now that do have something in between no wings and wings. And then, some people might say from a different perspective that proves evolution is doing something weird or it doesn't really work. Well, there's still some advantage to having something that's not fully a wing. You can glide, it can help you thermodynamically to keep heat in, you might use it as a mating gesture, those kind of things. So evolution works in gradients. It's not A to B, it's more like A and then every single shade of A and every single shade of AB and every single shade of B and then B. So it's a branching kind of thing. It's not like rungs on a ladder. All that being said, what's one of the coolest evolutionary adaptations that I know of? That's a hard one. I like the fact that something that's really cool in evolution is what's called convergent evolution, where animals that aren't closely related will evolve the exact same answer to a problem. So bats, for example, and dolphins both echolocate, but they're not closely related. They independently came up with the same answer to the same problem, but used different mechanisms in their head and tiny squeaky faces. What's amazing about that is that if you think about it just physics-wise, they're on the same planet, they have DNA, they are both constrained by environmental forces. If they have some level of the same genes, the same environmental pressures, them coming to the same conclusion within all of the possible conclusions in this big mathematical equation we call life, that kind of makes sense, right? You'd expect some convergence in some evolution. So I really like convergent evolution. And it gets even more fundamental than that, where different lines of animals can independently evolve eyes. I think a few dozen times eyes have evolved independently, where many different lines of animals have said, wow, it'd be great to have eyes. And it happened. It didn't all come from the same line. That's incredible to me. That's nature and pressure and all these factors at work, and it's really cool to see with eyes. What's next?
From DCO01.
I don't think I answered that question.
Do you have a pet? And if you do, what's its name?
I have many cats. I'm not going to tell you their names. Because some information needs to stay personal. But I do have a couple cats. And I've had them for a really long time, and I love them dearly. What's next?
From Anjali next. Speaking of the snap, would that loss of mass affect the Earth's rotation or speed through space?
Someone has asked me this question before. I'm going to do this off the top of my head, so forgive me. But if we say that the snap was 15 billion kilograms, the mass of the Earth is 5.9 times 10 to the 24th kilograms. Now, of course, if you remove any amount of mass from the planet somehow, it's going to affect what that planet does physically, sure. But would losing this amount of mass from that amount of mass, which is, a 10 trillion times larger, you can see that if it had any effect at all, it would be so incredibly small, it would probably be insignificant. And you can put this on a scale, right? We know that the tilt of the Earth and rotation and stuff can be affected by shifting masses when there is a massive earthquake. We can actually calculate that. And there is no way that just moving this much mass around is the same as moving like continental plates around. So if the snap happened on Earth, even though technically something would change about how the Earth moved. Wait. We can be even more technical. The mass is not going away, is it? I mean, not, at least in the portrayal in Infinity War, what happens to the ashes? They blow away, but they are still within the Earth's gravitational pull. Presumably, that dust settles somewhere. If there is gas produced because it's evaporating all of a person's water, for example, that gas goes into the atmosphere. The ash is still on the Earth's surface, and so during the snap, the mass of the Earth doesn't actually change at all. And so not only would this not change it very much, so much so that it would be negligible if you actually remove the mass, it literally doesn't change the mass, so nothing would happen. What's next?
From Alison Ross.
Hello, Alison.
Is it true that you can go blind by staring at the sun for too long, or is it a myth?
Don't stare at the sun. Yeah, don't stare at the sun. It's not a myth. There's good reason why you don't stare at the sun. If for nothing other than, think of, Allison, you probably have used a camera in your life. A camera works by letting in radiation into some aperture, and then it produces an image. And usually, when you click on your phone's camera or something like that, if you still have a shutter sound, even though that's not what it's actually doing, even if you have a shutter sound, you know it happens pretty quick, right? That's because if you let in too much light, the photo is going to be overexposed. It's going to be blown out. It looks like there's nothing there anymore. And you can see this in time-lapse photography. If you just keep the shutter open and keep absorbing light, those sensors at the back of the camera are going to get overwhelmed, and you produce an image that is nothing. Now, transfer everything I just said to your eye. What if you kept your eye open and absorbing radiation from the sun, which can be very intense, and just kept it open and kept hitting the sensors in the back of your eye for an extended period of time, right? They would get overwhelmed. They might even be damaged by that kind of radiation. I mean, blink. I mean, blinking helps. This is a reflex that helps sometimes get out radiation that we don't want. When a laser passes over our eye, there's a blinking reflex that actually saves our eyeballs. So, do not stare at the sun for too long, because like overexposing an image in your camera, it will overexpose the sensors and the rods and cones in the backs of your eyes and your retina, your sensitive tissues, to radiation that it cannot handle for extended periods of time. It could end up destroying it or damaging it, which could affect your vision temporarily or forever. Don't stare at the sun. Unless you have special glasses to do so, and they're eclipse glasses, then do it carefully. What's next?
From Darren Littleton.
Hello, Darren.
In Magic the Gathering,
Woo!
do you run a monocolored commander deck?
So I've been playing Magic the Gathering for 21 years or so, and I mainly play Commander or EDH, and I have 17 working decks at the moment. So I have one of everything. I don't have one of every monocolor, but I do monocolor, double tri, quad color, and 5-color. I will say, though, that I have a monocolor green deck, a Savala Heart of the Wilds deck, that I've built to be so aggressive and competitive because people keep challenging me in random stores because they heard about the deck on the command zone. I've made it so aggressive that it wins turn 3, turn 4, turn 5. So yeah, I do run a monocolored deck, and it is hyper aggressive. But I like to have a range of decks, right? Not all of my decks are competitive level. I like to say, okay, well, what are you playing? Something kind of casual, just want to have fun, just play a long game. All right, well, this level is good. Or mid-range. All right, so a little bit of good interaction here. This is pretty powerful. We're doing this. Oh, we're bringing out the big guns. All right, I got one of those too. That's my mono green deck at the moment. Selvala. Whew, she is strong. What's next?
From Mr. Fizzy.
Ew.
What is the scariest?
Do you fizz? Does your skin fizz? Do you open your mouth and you sound like you had Pop Rocks?
What is the scariest, most realistic thing you have seen depicted in sci-fi?
Scariest, most realistic thing. There's a moment that in Annihilation, which is pretty frickin' rough. I mean, if you haven't seen it, I don't want to. It's like a hybrid of different creatures, and it is terrifying. Other things, I mean, it doesn't really scare me. I know when things are scientifically accurate and portrayed in sci-fi, it's like I'm less scared, and I'm more like, hey, that would really happen. Nice job, whatever I'm watching. So there's something like that in The Expanse. in season 3, near the end of it, a guy is traveling at, orbital velocity, very, very, very fast, and then he has reduced his velocity to 0 almost instantaneously, and he turns on screen from a person like me into like blood spaghetti, like. And it's grotesque and horrifying, and also, that's what would happen to Picard and all them when they stopped. Unless you're warping space and time around you. But that episode of The Expanse is great. And they do a good job of that kind of thing. One more?
Yeah, one more.
Sure.
From Gladzette.
You don't want to turn into blood spaghetti.
What's your favorite sciencey bit of knowledge about climbing?
Okay. About climbing specifically. I think when a lot of people start out, they have their arms flexed, right? So they're bent. So they grab onto something and they come up and they hold on and they get really tired. And what that's in effect doing is using all of these muscles to stay on the wall. What you can do if you want to take advantage of biomechanics is instead put all of the weight on your hanging with your skeleton. So if you are just using if you're still using your hands, but you're hanging instead, then you're putting all of that weight on your skeleton instead, less so on your muscles. And so you'll use a lot less energy if you are much more deliberate in climbing. If you really focus and you hang, look at where you want to go next, set your feet, use your leg muscles first to start the pushing process because your quads are a lot larger than your biceps or your tris or what have you. Start with your legs, look where you want to go, grab the next one, start hanging again, put that weight on your skeleton instead of your muscles. That's one surefire way to get you climbing harder, faster, longer, stronger. Touch it, bring it, babe, watch it, do it, format, tracks, rename it. I don't know. It's a Daft Punk song. Thank you so much for watching this edition of Because Science Live. It's been a week, and Endgame is out. I hope you all have a chance to see it. It is a culmination of 22 movies, and you can be sure, even though we did not want any spoilers for this or in the previous episode that came out yesterday about the Infinity Gauntlet RNG stuff, we don't want any spoilers in there, but I can tell you that we are gonna get into the end game. We're gonna try to figure out a lot of the stuff that happened to the best of our ability, and that will be coming, and then that will be very spoiler heavy, but I will tell you, so don't worry. Next Monday, is the final episode of the Science of Mortal Kombat. It is the 6th and final episode where we try to cut someone in half with a chain. That's hot. Yeah, it sounds ridiculous because it is. You're not going to want to miss that. I've had a lot of fun doing this series. Hopefully we can do another one soon. But you're going to want to check that out on Monday. And then on Tuesday, we have a new vlog. Thursday, new episode. And Friday, another live stream. And I'll see you then. Until then, have a wonderful weekend. And be nice to each other because this is all we got.